Hey guys, so welcome back to the channel. In this video, we'll learn how to implement an arrow shot from the bow and getting stuck to a wall. Something similar to this. So the method I'm using is a line trace. So you can use the line trace method in two ways, by C++ or by Blueprint. If you are doing it by C++, you can use a line trace by channel. So with this, you'll have a start position and you'll have an end position. You need to give the start position as the actor location and end position from the actor's forward location to the this one. I'll not do it by blueprint as there are a lot of videos which implement it using a blueprint. So let me do it by C++. So let's go to our C++ class of arrow. Okay, first we need to have an arrow C++ class. So let's go to a C++ class. Let's create a new class. Let it be pawn. Next, this be array. Okay, the compilation is complete. We have an arrow pawn. Now we need to go back to our C++ to the blueprint and change this arrow BP's default parent class from pawn arrow. Okay, that's changed. So let's go to our arrow class. In arrow class, let's have a u function which is blueprint callable. Let this be a bool value. Check if wall. Then we need to implement it in C++. So that is bool. Check on wall encountered. So this can be called from the blueprint. Okay, so this is the implementation which I have done. So I have added a new u function which has a blueprint callable, which means it can be called from the blueprint. And the name of the function is check on wall encounter, and it returns a bool type. Now, if you go to our C++ of arrow, this is the implementation of check on wall encountered. So first we need to have a f hit result, which basically sends out a hit result when I encounter a wall, and this is the starting position of the line trace, which is the actor's location. We need to get the end position, which is basically consider this as the arrow, and we have the starting position, which is the location of the arrow, and the end position is the length of from the forward vector of the arrow to the end length. End length will be set in. So end length is a variable which can be edited anywhere. It's a float value. So consider end length as something around 2000. So this is the starting position plus forward vectors 2000. So this will be the end length. So the line trace will start from here and end here. A line will be drawn there. And F collision params. We need this to ignore our actor. So the line trace will ignore the current actor where it is coming from. So we need, for our purposes, we need to draw a debug line, which is basically a red color, and it has the start position and end position, and we are adding a lifetime and other miscellaneous stuff. So this will the draw debug line will draw red color line. So now we need to have a bool is hit, get word, and line trace by single channel. It takes in the parameter out hit, which is basically like when we hit a wall, it will be populated. And it has a start position, it has a end position, and it's always visible, and we are passing the collision params. So this is an important function which draws the line trace. And when once you encounter a wall, the exit will be true. Otherwise, it's a false. So now, once the exit is true, we check the hit location's value. How can you check the hit location's value? Previously, we had a F hit result, right? We got the result of that. Then we check the actor's locations value. If this actor and the is hit, the line trace where it hit is the same, that means the actor is at the wall, something like this. And then we return true. Otherwise, we return false. That's basically what this method does. Now coming back to our blueprint class, that is arrow underscore BP. Let's open arrow underscore BP. So here in event tick, we can call the check on wall encounter. This basically calls the C++ class, and it returns when the actor's location is equal to the line trace hit location. If it is true, then we stop the projectile movement. So basically what you can do, you can drag this projectile movement and you can set the velocity of this projectile movement to 0. So the new velocity is 0 of this particular projectile movement. This will this will stop the arrow from moving forward. I've also given an initial speed of 5000 and a max of 5000, and let's give a gravity of 0.1 and then run the game. So as you can see, the arrow just stops in its place and doesn't move forward. Thank you for watching the video. If you like this video, please like, share and subscribe as I continue the series. Thank you.